Good morning, student. So, today we'll discuss basically some more examples of recursion. Yesterday, we have discussed that what is recursion actually. So, just let join few more student. Within 1 minute, we'll start the session. So, today we are beginning with some more example of recursion. So, yeah, good morning, Chandan. Okay. So yesterday what we have learned basically what is recursion, what is the basic condition of recursion. Condition means you need one base case for each recursive function. Without base case, recursion will not work or not fruitful practically. So today basically we will discuss about some more example, and basically today is the last day of this chapter, and from Monday onwards either we'll go for some practical things or we'll basically go move to new chapter. So just as I told yesterday only, this is a continuation chapter of function only, and with new concept. So here today I will, that's why today I will discussing I am discussing some few more example. So let's go move to the first example. What is the first question? Question is a recursive function to print a string backward. Print a string backward means what? If you have one string ANPS, so it will be printed like SPNA. So just to print a string backward. So if we have done this through loop, so we know very easily that we have to run a loop backward. Yeah, good morning, Aman. So we have to run the loop backward, and we have to print each and every character in a backward way. But here we have to do the same thing in a recursive manner. So let's see what will be the logic. So here is the logic. Dep here, yeah, Pooja, good morning. Dep BP means one function name, just backward printing. Here I am passing two parameter. S means string, and N is the length of the string. N is the length of the string, or simply the position of the string, each character. So here is the case. If n greater than 0, so print s of n comma end equals to single quotes. Now what does it mean? When n is greater than 0, when n is non-zero or positive or simply greater than 0, simply will print those particular character. So for example, here is our ANPS. Okay, we'll go to example later. First of all, let's try to understand by the code only. So if n greater than 0, here first we will print the particular character s of n comma end equals to single quotes. Okay, Ritesh, welcome. Then BP, that is I am calling the function again, the backward printing function BP s comma n minus 1, that is each position of the character will be subtracted by 1. That is, first if n is 5, initially if n is 4 or 5, then from 4 it will reduce to 3, then reduce to 2, reduce to 1, and ultimately when it will goes to 0, then ultimately it will return that 0th position character. It will return 0th position character. So let's go for one example. Through that we'll try to understand. So here is our word s equal to Python. This is my word. For the basic information, what will be the length of this string? Because here 5 characters are present, 6 character, 1 2 3 4 5 6, 6 character is present, so length is basically 6. But we know very from the very beginning only that when we want to fetch any particular character, we have to start from 0th index. So 0 to 5, the index of this particular Python will be 0 to 5. This is 0th position string or 0th position character, and this is 5th position character. And backward printing means we will start from here, that is a node h. The output should look like this, a node h typ, like this. This will be my output. So let's see how we can manage it. Here from the main we are passing the character, passing the string bps comma len of s. Len of s, what will be the len of s? That is 6. 6 minus 1, that means we are passing here through this point, we are passing 5 because our S is Python, it is of 6 character. So when S and 5 we are passing, it will move to here or goes to here, copied here. Now here you can see n greater than 0, that means simply I am running one line, 5 greater than 0. So this option is correct, here one colon will be there. So 5 is greater than 0. So print S of n comma n equals to single quotes. Then what is the meaning of this line? If n greater than 0, print S of n. So first of all, this n will be printed because value of n is now 5. Value of n is now 5. The fifth position character is our n. So after n, the cursor will remain in that position only. Then it is calling the function again, bp s of s comma n minus 1. The value of present value of n is 5. So 5 minus 1, 4. It will send now 4 to this function, and s is that string only. Now again when value of s will be 4, so in that case it will simply print the next character, that is o, and then it will remain the cursor there only. Then when it is first 5, then 4, when it will come down to 3, it will be h, then 2 for that t, then 1 for that y. Now when it has printed the value 1, that is 5 greater than 0, then 4 greater than 0, 3 greater than 0, 2 greater than 0, and then 1 greater than 0. Now it has reached to 1, 1 greater than 0. bps comma 1 minus 1. Now it will send like this, bps comma 1 minus 1, that is it will send the value 0. So when it will send the value 0 to this function, here this particular condition will not work, then it will move to this condition, and this condition is here, if n equal to 0, that is our particular case. If n equal to 0, that means it has reached up to the 0th position, the print s of 0. So on the same line it will simply print the 0th position character, it will print the 0th position character, that is p. So you can see this is our base case, we can simply understand through the line. Base case means here it is stopping the recursive function, here it is not calling the function, just it is printing. But yesterday one point I think many of you have noticed, that one time I have told that basically recursive function needs one return statement, but I have chosen this example because here we are not using any of return statement. So this is one type of exceptional, you can understand, but basically this type of program or recursive function are basically written with return statement only. Since we are printing here only, that's why we are not using any return statement. So but basically for any numeric based problem or number based problem, we'll have to use the return statement. So I guess in this first program or this example, no doubt is there. If any doubt is there, I'm just waiting for a few seconds. Just type your query right in the chat window, chat box. So if any issue is there or any particular line is there, so you can also ask me. This is the string, this is the one recursive function that actually print a string backward. So just I am taking 1 minute more time to show you that if we want to go for in iteration mode, that is using for loop, how we can do that. Just I am showing, so that if you have any query regarding this, you can ask within that time. For I in range n minus 1 comma 0, this will be comma minus 1, here will be 1 minus 1, because we have to go negative way, from backward we have to print. Then just we have to print s of I comma end equals to single quotes. In this way we can print a string backward, but this is iteration mode. Iteration mode means we have to use a for loop or looping structure, and you know very well from the very beginning we are discussing about that only, that a recursion is quite different from iteration. At last, at the end of the today's class, we will discuss that also in a very brief way. And today I will send you 1 or 2 assignment question that will solve by Monday or before that also you can solve, and you will simply send it into the classroom app. Now I'm just, I think no doubt is there, so I'm just moving to the next problem. So here is one small topic is there. Already so far we have discussed, but this is just a simple topic. What is meaning of infinite recursion? You know very well that recursion must need a base case, but whenever any base case is not there, a recursion may call itself for multiple times or endlessly, and that situation is only called infinite recursion, when a recursive function calls itself endlessly. You can see here def a, one function is there, within the function it is calling itself, but there is no end situation. That means the function will call itself for continuous basis, it will not stop. So this type of function or this type of recursive function are called infinite recursion. Now I am just moving to the next problem. This is recursion function for GCD. GCD you know very well, greatest common divisor. GCD means greatest common divisor, or sometimes it is in general mathematics it is called highest common factor. Greatest common divisor or highest common factor. So here I have used the approach, but before going to the function, let me show the mathematical approach. We know very well. This is called division algorithm, and also it is called Euclid's algorithm. As you are math student, you should know this about what is this called, and you know very well in computer science, math and computer science are just goes parallel. So here is the technique, 6, 21. We have to find the GCD. So 6, I am dividing 21 by 6. 6 3 is 18. Remainder is 3. Now I am taking this remainder as divisor, and I am taking this divisor as a dividend. So I am taking 6 here. So now 3 2 is 6. So ultimately here remainder is 0. So ultimately when remainder will come 0, so that particular divisor will be called the GCD of those two number. So here GCD is 3. Here GCD is 3. You can see. Now this technique only I have converted into the recursive way. So let's see what is happening here. Recursion def GCD function name p comma q, two number I am passing. Here you can see if q is equal to 0, equal to 0, return p. If any of the number becomes 0, if any of the number becoming 0, so then I have to return the other number. And if this is the base case, and otherwise here I have not used any else statement, directly I have written return statement. So there is no harm if statement is there, and if we are not mentioning else, so by default after verifying if, it will go to the next statement only. So what is the return statement? Return GCD q comma p percent q, q comma p percent q. Now what does it mean? Q is our number and p percent q. P means, suppose p is here 21, 21% 6. So what will be the remainder? Remainder will be 3. So that 3 I am using for divisor now. So that's why I am converting q comma p percent q. Here you can see I have taken or received the number as p and q. But when I am passing the number again, here I am passing the number in this way, q comma p percent q. So this is the way. Whenever again it will move up and it will simply change the value. So this is the way of GCD, finding GCD in recursive way. You have just to pass two simple numbers, two integer number or two numbers, and then it will find the GCD. And from the to the calling function, it will return the GCD value. So this is the second example. Now I am moving to the third example. And this is one of the good example also, as well as very interesting one, because we have to understand very sincerely. So the problem is Fibonacci series. Most of you are familiar with this series, because in class 11 when we have done the looping structure, that time we used to have done this problem. Fibonacci series, what is the structure of this series? Let's understand that first. This is our Fibonacci series. Now what is the logic here? Here initial value is 0 and 1. So 0 plus 1, 1 is coming, 1 plus 1, 2 is coming, 2 plus 1, 3 is coming, 3 plus 2, 5 is coming, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21 and so on. You can write more terms. So here I have taken up to this term only. So let's see what is the how we can do this Fibonacci series. But before going to the function structure or recursive function structure, I will first try to demonstrate through the normal way. Normal way means it's diagrammatic representation. So here you can see one tree diagram is there. This is called actually Fibonacci tree. So my initial value is 5, n equals to 5. So I have to break, this is 5 means I need the Fibonacci terms up to 5th term. So this is the way. So 5 is there. So I have to break the term 4 and 3. I have broken into 4 and 3. Then I am breaking right side and also I am breaking the left side also. So 4, 3, 2. Then 3 I am breaking into part of 2 and 1. And I am breaking the 2 into part of 1 and 0. So you have to stop when the last value has reached up to 1. So you can easily understand now. 5 I am breaking into 4 and 3. Then 4 I am breaking into 3 and 2. 3 I am breaking into 2 and 1. 2 I am breaking into 1 and 0. And this side 2, this 2 also I am breaking into 1 and 0. Now I am moving to the right side also. 3 I am breaking into 2 and 1. 2 I am breaking into 1 and 0. So this is the structure of Fibonacci series, Fibonacci tree. Now I will move to function, recursive function, through which we will try to understand how it works actually. So we know very well, basically we need to initialize the first two terms. Here is the two terms are 0 and 1. So let's see. Dep fib means one function name, n I am receiving, n again I am repeating, n is the number of terms. Here how many number of terms? 1, 2, 3, 4, 5, 6, 7, 8, 9 or 8 term maybe. Okay, 8 or 9 terms are there. So that I am passing here. Now if n equal to 1, that means you need only one term, so only 0 will come. If you need only 2 term, so then return 1 will come. So this is the first base case, first two base case. And special, what is the special thing here? Here you can understand in this way, here two base cases are there. Till now whatever function we have done, there was one base case, but here you can understand there are multiple base cases are there. It can be possible, there is no issue. When you are writing a recursive function, we know that in a recursive function there are two things required. One is recursive case through which recursion goes, and second one is base case. But obviously base case can be more than one, multiples of one. Why? Because there can be multiple situation where you need to stop the particular execution. So that's why for time for the multiple time we need to have go for multiple base cases. So this is our example where there is two base cases. So now finally I am going to the else part. So in the else part, return fib of n minus 1 plus fib of n minus 2. This is very interesting part. Return fib of n minus 1 plus fib of n minus 2. Now what does it mean? As we know, the logic of Fibonacci series is there you have to add the last two terms, 0 plus 1 1, 1 plus 1 2, 2 plus 1 3. So whenever you are running to a particular term, so you have to go in this way, fib of n minus 1. Again I am going to this part, when 5 is there, so fib of n minus 1, fib of n minus 2, 5 minus 1, 5 minus 2. Now you can understand. Again 4 is there, so 4 minus 1, 4 minus 2. 3 is there, 3 minus 1, 3 minus 2. So this is the structure. Return fib of n minus 1 plus n minus 2. This is the way how can to print the Fibonacci series. And obviously here it is adding up. So adding up means ultimately it will add these two number. It will add this two number. So that's why we are breaking the whole Fibonacci series into this main part. Now for this particular problem or function, we need to see the main also, because then it will be more clear to you. So I am taking here n is equal to 8. You can see for I in range 1 comma n plus 1. What does it mean? It will simply go up to 8 term, exact 8 term, because n plus 1 I am writing, that's why 8 plus 1 9. So by default it will go up to 9 minus 1, that is 8. 1 to 8 terms. Then print fib of I. Print fib of I. So when I is 1, for example, you are passing first I. I means 1 here. So this I will pass to this part 1. So first of all it will print what? It will print 0. For this part it will print, at first it will print 0. Then I will be increased by 1, that is 2. So when it will pass 2, it will return 1. So after 1 it will, after 0 it will print 1. Then the next value is 3. Then the next value is 3. So then neither it will go to this part, neither it will go to this part. It will directly go to this part. So 3 means when we are passing 3, what you can see? 3 is broken into 2 part, 2 and 1. 3 is broken into 2 part, 2 and 1. Then 2 into broken into 2 part, 1 and 0. So that means when we are passing the third term, 0, this is 1 term, 2 term, and this is third term. So third term is 2. It will break into 2. So when it will break into 3 minus 1, 3 minus 2, 2 and 1. There again it will call. So 1 and 0. Ultimately it will print the third term 1. So and so on it will carry forward. So this is the way how we can print the Fibonacci series using recursion. So if any more doubt is there regarding this part, these are example I am discussing, because as I told, in this chapter we will get very few example, and those example we have to learn very carefully, because those examples will be repeated time by time. So now the very important part, or one of the last, you can say, last topic of this chapter, that is binary search. But as I can remember, in class 11 once I have discussed this binary search, but today obviously I will again discuss it, rediscuss it. After this binary search discussion only, you will have two assignment. Two assignment means, first of all, I will not discuss the exact program. I will discuss the algorithm with you, and I will try to demonstrate the way how binary search works. And then you will have two assignment, two question, that you have to write a general means without recursion, normal user defined function of binary search. And second, you have to write one recursive code of binary search. These two things you have to do by today, tomorrow. That means by Sunday you have to submit this two assignment question. And remember, whatever I am giving for assignment, those are very important basically for board, because I am just preparing your whole notes as per board standard only. I am not going into too much deep. I am not going into very little concept only. I am just focusing on your board. What are the things I know? There are various subjects are there, lot of pressures are there. So just I am concentrating on those whole topic, and because school is also not there, we are going through online classes. So lot of things are there. So that's why whatever I am suggesting you, try to go through the things. So now next I will move to the explanation of binary search. This is our algorithm. You know very well, the algorithm means when a particular program is written, before writing the actual code, we can write for one demo type code. Demo type code means just one word expression. Simply you can say one word expression. Word expression means through which we can simply express our possible area, how will work, how the program or how the code will work. So here is our algorithm. Algorithm means, first of all, you have to need to know what is the meaning of binary search. So first, binary search means, by searching means, suppose I have one list of number. For example, 10, 12, 15, 20, 21. These are the number. I want to search for 20, whether 20 is present in my list or not. So through binary search, either we can search for the number, or there is another technique that is called linear search. So linear search will not going here, that we have already done in class 11. But now this binary search we have to do. Binary search has a different technique, and that technique only we have to understand through this algorithm, and after that I will demonstrate one example also with you. So let's go for that. First of all, I want to search for this 20. So basically this 20 is here. You can understand this item. Item means I am taking this 20. So and mid, you have to know some few more words, that is mid position and last position and beginning position. Big, mid and last. Three words you have to remember: big, mid and last. Whole program basically depending on these three particular variable: beginning, mid and last. So AR of mid equals to item. If the item is found on the mid position only, so that is end of the program, at the beginning only. Now if not found, let's see what is happening. If AR of mid less than item, for example your item is here and your mid is coming here, your item is here, your mid is coming here, so obviously your mid is less than item, your mid is less than item. So in that case what you have to do, last you have to move mid minus 1. Now what is last? This position is called the beginning position and this position is called the last position. So this last position, that is the 0, 1, 2, 3, 4, this is fourth position. So this last you have to move mid minus 1. Mid means 0, 1, 2, that is 2 minus 1. This you have to do. And on the other hand, if AR of mid greater than item, for example you are searching for 12, you are searching for 12 and your mid is 15. So 12 is less than mid, 12 is less than mid, that means 12 less than mid, that's why you have to go right side. So in that case what you have to do, mid plus 1, you have to go beginning goes to mid plus 1. There are the two cases. This is the algorithm part, and through this algorithm you have to write two code, that is one user defined function of binary search and recursive code of binary search. This will be your two topics, two assignment question that you will finish by today. Basically today is the end of this chapter. I am sharing you rest note with you, and after that means on after Sunday or Monday I will take another practical session, okay, if possible. Then within that session I will try to demonstrate some more feature or things, or simply some few more example. So whatever things I am today sharing with you, and obviously note one thing, when I will share I will mark something just like any tick or any special word. So try to write those things as assignment also in your copy. Try to remember this part. So here I am closing today's session and I will share notes in your Google Classroom. And again I am just asking you, if any friends are there, those who have not joined in your classroom, so tell them, inform them to join, because within very short time we are beginning with some more things. Without that they will lose many things. So and for you also, take it very seriously, sincerely, because this time is crucial time only, and after when we'll move to end of the session or goes after just like November, December, that time you will not get enough time to co-op with each and every chapter. So concentrate on each and every topic. So I am closing today's session. Thank you student, good day.